All right, so today we're doing 614. You're going to need a piece of graph paper out.
What?
That should not be a surprise.
Yeah, it's not a surprise.
It's a disappointment.
Yeah.
Wow.
So what, if I told you get out lined paper, that would make you happy?
That would actually be more
He told me
disappointing
get
because
out
I don't know
Desmos.
where to get lined paper.
If I told you to what?
Get out Desmos.
That would be good or bad?
That would be good.
Yeah.
That'd be good.
Jake likes anything he can do on a computer.
Honestly, yeah.
Really? You don't like ordering hamburgers from McDonald's on your
No, I
computer?
don't. Because I'm vegetarian.
Oh, yeah. You don't like... actually, I don't think
Ordering
they
a
have
salad?
hamburgers. From McDonald's?
No,
They have
from,
burgers at Burger
You don't like ordering North Star burgers on a computer? Have you been to North Star?
Yes. I used to go all the time when I was little. Then we moved there. There's one near our house.
All right, we ready?
There's a North Star in Worthing.
You guys are so happy.
We hardly ever go. It's sad.
you go to wrestling,
The
right?
only place
Yeah.
You know this kid named Grant Donner?
Yeah, I think so.
Jada knows somebody that Connor knows.
Wow.
Wow.
Zowie.
Amazing.
All right, we ready? All right, you were talking about friends from camp, so I figured I would give you.
Friends from
I
camp.
don't know. You were saying
I'm
something
gonna
about do you know
assume-
so and so?
Friends from
All right.
elementary
So
school.
when we raise a number to a power, yeah, this is probably going to be a pretty quick lesson, but depending
And
on
then we can go back to that public
It's
argue
three.
again.
when we raise a number to a power, what's that mean?
It means multiplying it by
It
itself.
means repetitive multiplication, right? So if instead we raise that power, or we raise that value to a power that is a half,
No, wait, that's negative
Ooh.
exponents.
yeah, so wait, repetitive division.
No, that's negative exponents.
That's negative exponents are division because it's the opposite, right?
It's
The
probably gonna
opposite
give us
of
an error.
multiplication. So we're multiplying 9 times itself half of a time.
So we're multiplying 9 times 4.5.
I don't think is that what that means? I don't have a calculator out.
And
Ooh,
you're a silly
that's
guy.
gonna be tough.
Yeah.
My battery's been low forever.
Jake calculator is gonna die. I'm not gonna have
Three!
it now.
Three! I don't, okay.
What about this?
Oh, it's the square root. Okay.
I bet it's three. No, I didn't do that right.
It is 3.
Oh, I guess it.
Whoa!
What about?
Wait a second.
Sorry, that is a
That's-
power,
I
although it
bet
barely
that's
looks
a
like.
9, but I'm not really sure.
Oh.
9, yep.
Oh, I was right!
So
Oh.
fractional
Wow.
exponents are a shortcut. Fractional exponents allow us, instead of writing the third root of 27, we could just write 27 to the 1/3 power. However, what's this doing?
It's doing that.
And then
That times-
squaring it.
That's square.
And then we square it, right?
Yeah.
So
Oh.
49 to the half power
7.
would be 7. 100 to the half power,
1.
10.
10.
But we're forgetting something.
Negative x numbers even.
The negative value of the x, because our roots are even here. Right? So with even roots, we have to remember there are actually 2 real solutions. But what would happen in a situation like this?
Well, it'd be the square root of 7.
It'd
It'd be
be
7.
7.
It'd be 7, right? Because it's the square root of 7 squared.
Or you can multiply the 1/2 by 2 to get 1.
So essentially what a 1/2 power is saying is find the root, find the edge length, right, of a square of that size. Same thing with cube root. If I give you a cube that has a volume of 27 and say find the edge length of that cube, that is what the cube root does. It's an actual cube, and we're looking for the edge length. Cube rooting, the volume, finds that edge length.
That's useful.
So, 16 to the 1/2,
16 to the 1/2.
4, right? Because if I have a square root of 16, what is the edge length? It would be 4.
2 5, 9,
You're like a
9, and then ooh, I should know that one.
Radical 5? No.
so
that's
the
not right.
fifth root of 32.
Yeah.
I should probably make that look like root.
So the third.
So
Wait,
what-
so is it radical 2 32?
So
Or no, like,
what
square
number
root of 32?
to the fifth? Sorry, I need to
2, 2, 2, 6. I think I got English.
2 times 2. 4, 8, 16, 32. Okay, so 2 to the fifth, but then what?
No, wait, no, that's what?
I don't get what you're
We're
talking
looking at this one.
Cube.
Ah, then we
Oh, yeah.
cube
So
it.
it's 8.
So it's 8.
Yeah, yeah.
Now wait. Does order matter here? Like, if I'm going in order, wouldn't I go top down? So what if I do 32 and cube it, and then take the fifth root of it? Do I get the same answer?
Well, let's see.
You should.
Wait, cube it and then what?
And then take the fifth root. Or do the 1/5 power.
How do you do the fifth? Oh, wait, no, I don't know. Do I know how to do that?
Yeah, it's easier on your calculator to do fractional powers than it is to do roots. Well, depending on how quickly you can type buttons.
How do you root it though? 'Cause it-
Fractional power.
Oh, okay. That's
Ah, that's why I'm teaching you this.
I don't like calculators.
Nor does Nick. That's just something I
Nick doesn't like math.
It does work. That's cool.
Wait, is it the same, you mean?
Yes.
Oh, because exponents doesn't take up 2 steps in the order of operations.
Yeah.
All exponents can really happen at the same time, or like,
Simultaneous.
yeah, kind of like simultaneously in a way, right? Because if we're saying that order doesn't matter, then essentially, yeah, I kind of like the word that you use, saying like, well, they happen simultaneously. We know that math can't actually do 2 things at once, but it doesn't matter on the order, so you can do whatever
What
you
is
want.
it called? Is it just called the fifth root?
Yeah, so 5th root, 6th root, 7th root, at a certain, after Q, but we don't really have a physical representation for it.
Oh, but if you say like 5 radical, that means 5 times the radical amount. So there's no real way to like shorten
Yep.
it.
If you say like 5
Whoa.
radical 32, that means 5 times the square root of 32.
I don't like
I don't like you.
that. Wow.
Hey, it's nicer if you say I don't like your attitude.
Attitude.
So,
Okay.
this takes us to some interesting problems when the numbers aren't nice. Right, like the third root of 17. Yeah. Gross.
Just leave it. Like, huh? It's the third root of 17.
Is there a way that we could write out a reasoning of why?
Why what?
Why this makes sense? Why this works? Like saying, well, because our calculator did it for us, isn't
Oh, I can do
really.
it. I can do it. 17 to the first equals 17. And 17. Cube root 17 equals cube root 17.
What?
Wait, a word is a word?
So wait,
You can't.
hold up. What you do?
What to do?
I know how to do it. I just can't really explain it.
Okay.
Oh, you got the memo. It's flannel day. You got the memo.
Oh, it was?
No, it's
Oh my
still a
God.
lot of people are wearing flannels. So yeah.
Okay, this
It's probably Logan, because he just always does that.
I'm a fan of flannels.
Write in good handwriting, please. Well, I mean, I kind of do because then I'll be able to read it, but okay. Just
I'm not sure if that really actually defends. Like, if somebody came in and said, "I don't believe you. I think you're wrong."
I totally
Calculate.
get
Right.
it.
So this is at the basis of like all mathematical proof and argument, and us talking about like Gödel's proof that tells us that we can't prove things.
I know he ruined people's life. That was so sad.
Well, so did the Pythagoreans. I mean, math was kind of intense back then.
They like kill people.
They killed.
Yeah, they killed people over math. Not a joke.
Yeah.
Didn't they like drown somebody because he like was going to tell Pythagoras that this thing he was trying to solve was impossible?
what if we go back to the B, right? Because 3 is a bit easier to work with than 17. But do we know what the square root of 3 is?
It's
I mean,
like
we talked about it
1.7.
yesterday. Yeah, we talked about it yesterday. It's like 1.7, but it goes on forever.
Yes, it does.
So that's not super convenient. We'll leave this here. We'll come back to that.
Let's do 4. 4 is a nice
So
number.
square root of 3 equals 3 to the...
1/2.
Well, if we didn't... So if somebody walks in and they argue you're wrong.
That'd be
1.
What if they say, I don't believe you that x is for sure going to be 1/2. So you have to prove it to them.
Okay.
Calculator.
No.
Because the
How? I know,
calculator
but
is based
you've already
on,
said it a
like,
couple times,
set
so we just gotta
rules
move
that
on.
someone made, so like that's not actually proving anything. That's
So,
proving that-
Is this right now false? No. Right? Because x can be whatever we want it to be. We don't know what x is right now. This is perfectly true. Because we just wrote a true statement. So what?
Square it.
So square both sides. Okay. So if we square this side, what happens?
You get 3 to the 2x.
So we get 3 equals
Oh.
3
2.
to the 2x.
So it is a half.
And then, so
No,
there's
it
like an imaginary one there, and then you do 2x equals 1, and then you divide it by 2, and then x equals 1/2.
So what we can really then say,
is 3 to the first, and then you can set if you
Ah.
equal to each other, you can set the exponents.
and if we were writing a proof, maybe something involving like that word identity that we talked about yesterday or whatever, like when we use 1, we're often using
So
that
is this a
identity
thing
word.
called the fractional exponent identity?
1 equals 2x.
So wait, so why? Because two values with the same
Same.
base
Yeah.
Are the same.
that are equal to each other their powers must be equal to each other, right? So same base, we can set these powers equal to each other. Now we can say 1 equals 2x,
Divide each side by 2, and then you get
and
1/2.
x must be half.
Of x.
Yay! And then we prove
Yeah, yeah.
you're wrong.
Man, that circle and that arrow was satisfying.
Yeah.
Thank you, I've only been at this for 10 years.
That's your entire job, thinking arrows.
Trying to make perfect circles.
He can look at he can look at other students.
No,
And
if
then
when I'm
write
trying,
it
it's
down.
too hard.
You need to try. Have you ever tried like with a whiteboard where you like hold the pencil down?
See, the middle one's pretty good. That one's pretty darn good.
Oh yeah. But you have the
Oh, I
calligraphy.
can draw pretty close circles.
Whoa.
Okay, it's pretty close. We're totally off on a thing that doesn't matter, but that was pretty darn. Come on.
He
That
can
was
look
close,
at
yeah.
he can look at
I
you
can,
and
I
I
can
on the
draw
board
pretty
like
good
this.
circles. Can I try?
He did it with
How about when you guys come back up here to deal with that system of equations?
Yeah.
Let's solve a few problems so I know that we know what we're doing, and then we'll go from there.
I draw
That's
circles on paper.
nice.
So especially if you're going to argue to me that you want to use your calculator, there's a much more efficient way to type these things in, and there's a less efficient way. The most efficient way is literally just using your caret and then a power in parentheses. So what we want to get to the point of is being able to say 3, and in the calculator we would hit caret, but we don't have to write that, parenthesis, something in there, and that's our power. So in this case, what would it be?
That would be 9.
Well, but what would we, okay, we're going to start with easier ones and then get more, so what would we write this out as, and then it will become 9.
2
So 4 power divided by the second root, right, but 4 over 2.
Wait, it is?
Look, there's a no calculator symbol up there.
Oh, sorry.
You're breaking the law.
Mr. Hudson said to use our calculator.
No, I said if you're going to argue using your calculator, we should be able to type it in the efficient manner.
Oh no, I
Silly
like
Connor, you're
calculators.
illegal now.
So, if this is what we're typing in our calculator, what it's actually doing is,
4 over 2.
well, okay, so that,
So
sure, we agree there. What about B?
3 says that I think is fun. Everybody knows.
Square root of 9, right, to the 7th power. And we said that order doesn't really matter,
So 2 to the 7th.
so I guess we could kind of do 9 to the 7th power under the square root also if we wanted to.
No. Just
Yeah, this is a better way to write
Yeah,
it.
it is.
Right, so
32,
this becomes 3 to the 7th.
Which is like 2,182. I don't know that off the
I think
top
it's
of my head. That's like what my-
2040.
I think it's 1024.
1024, that is a power.
So wait,
It's
I don't
2,187.
87.
So wait, why
87?
would square rooting it get rid of a 2 in the exponent?
It's wait.
Because the
Oh yeah, because it's squared. That's silly.
So, what we're actually looking at here is base value to the power, might as well say P, divided by
the extra number.
3.
Oh.
Seriously. Because what this is actually doing is whatever your denominator is, that, I need to quit making this look like division. That's your root, and the numerator is your power.
Why is it with exponents that you always add something like invisible? Like in the beginning, you just had 1, and then you learned it's actually 1 to the first, and now you're learning it's actually 1 to the first over 1. Why?
Because if we gave it to you all at the beginning, you'd just walk away. You'd just be like, forget this.
No more.
So now they've got that power under the root. How could we rewrite this in exponential form? So this is radical form because it's using the radical. How can we rewrite this in exponential form?
2 squared. Oh.
2 and then 5.
Yeah, 5 over 3, right?
Yeah, that's not 2 squared.
For the 5/3.
Sweet.
So you do
So
radical.
you do cube root 2 times to the 5th.
Take a moment. Take a moment on your own without talking. Write down either 1, 2, 3, 4, 5, 6, 7, 8 or A, B, C, D, E, F, G, H. And then we're going to go through these together and say, what do they match to? Right? But take a moment on your own so we each get to think on our own first. And so I get to drink coffee. Who what? They all only match to 1, so there's no tricks here. And none of them get used twice.
Oh, no, I don't like this. Oh, never mind. We didn't even learn about that.
Yeah, we have previously, though. The negative powers.
No, the division of exponents.
What happens when you have a power to a power like we see in H?
You multiply.
We multiply them, right? Power to a power multiplies. I'm going to cut things so we can actually work in the smartboard. Give me just a second. I'll go back there in just a second. Took a snapshot. Yes, it has an audible snapshot when you take a screenshot.
Why?
Because it's silly. I mean, your phone makes a shutter noise when you take a picture unless you turned it off.
Yeah, you can just turn your phone on silent. So. It's like a little.
I think there's a more efficient way for us to deal with this problem, but I'll let you guys figure that out.
It'll probably.
Well, I mean, I already solved it, so, flex.
You started it.
1. What does a 1 equal?
Yeah, by about 20 years.
Wait, really?
Well, I am approximately 20 years older than you, so. Which is weird to say out loud.
Why?
Like, obviously I'm older than you, but the fact that there's a 20-year gap between us, that just feels weird now. And because, like, especially you guys, I relatively look at as, like, equals, aside from, like, you don't get paid for coming here, I do. So aside from that, like, we're all just coming to work, right? Like,
I wish I could get paid.
I mean, I'll give you a piece of candy if it'll make you feel better. No?
Wait, so
I
I just have
need
a
a
question.
Yes.
You worked at Phoenix for 10 years, right? Or is it?
I have never, aside from substitute teaching, I have never had a teaching job elsewhere.
Were you
So,
in the beginning,
okay.
Phoenix? Or
So the first year that you were teaching here, was there a car crash? Do you, if you were? I don't
Probably a
know.
car crash every year.
Okay.
Why?
a car crash at Phoenix?
No, yeah, it was basically in front My mom crashed into one of the trees
Oh,
10
interesting.
years ago.
When it was like snowing or something, or
I think kind of.
was she texting and driving?
No. Her tea fell on her and then it was really hot. So it was like the
Yeah.
whole thing and then she
Either pain or car crash.
All right, we ready to review these?
Assume x
You're
is
not
greater
ready to
than
do
0. I didn't see that part. But yet I still solved it the same. So I feel like
What
I
about
did
in
something
G
wrong.
when we have a power times a power?
add them together.
We add them, assuming their bases are the same, right? So we're saying same bases,
Well,
we add
X
them.
and-
I'm assuming x is equal to x.
Yeah.
X is X,
Like,
and it's greater than 0.
that might be wild, but that's
Alright, I got it now.
We're good now?
I was
Connor, you good?
yeah.
Akshay?
Yeah.
Did everyone list it A, B, C, D, E, F, G, H?
Well, that's how I'm going through it.
I did.
A matches with
3.
3. X to the 3 halves. B matches with
8.
Ooh. Whoa! All right, somebody make an argument.
Wait.
2
No, because 2
minus 5 is negative 3.
Oh, yeah.
That's my argument.
So it's 8.
Oh, yeah.
It's 8.
Yeah.
I said.
Alright, because power divided by a power
wait, okay.
subtracts. Right? Power
That was
divided
on the
by a
homework.
power subtracts.
Oh no, that wasn't on the homework. That was on the homework
Okay.
question that I did. That we
I
couldn't
mixed
use
it up.
because-
So B is 8. Right? B is 8. C, so much confidence. Yes, it is 7. D,
1.
Ooh. Jake,
You
I
have
think
to
you're
flip it
working too
over.
fast,
Yeah.
man.
I
I think you're working too fast.
Well, he had already listed one. I think he was one.
Oh, yeah, he already ruled it out. Alright, D is 1. E, yeah, E is 6. F,
4.
4. Now, you had already used 4 elsewhere, but yeah, F is 4.
Wait, what did you put?
Anything, or maybe I just thought I heard somebody say, or no, I thought I heard you say 4 earlier. Any value to the 0 power is one. Why? Who can remind me why this makes sense?
Because
How could
exponents
you-
are technically 1 times the number, the amount of times it is. I think.
How could you defend or come into like one of my 7th grade classes and say, hey, this is that?
Okay, so put 3 squared up there. Three squared equals 1
That's not true.
times. I'm saying it in coaching. 1 times 3 times 3. Defense.
That makes 3 to the 0 equals.
But this doesn't equal that.
No, but 3 to the 0 equals 1 times 0 threes. So it's just 1.
There's a better way. Because I'm here to show you the better ways. I'm just being honest. There's a much better way.
Aw, I thought I had figured it out.
You did. That one, I would believe you.
There are rules that we use with our exponents, right? What if I did this? That'd be 3 to the 4th. So instead, what if I do this? Any value divided by itself is 1, right? We learned that a long time ago.
Except
And
for 0.
Exponents,
Then it's error.
yeah, that's 0 breaks things. Exponents, when divided with the same base, subtract each other. So since we know that this must equal 1 because it's a number over itself, and we also know that it must equal 3 to the 0,
It's there's a property for that, right? Like substitution,
Giant
rearranging.
1.
The giant
Giant
Equals
one.
1 equals.
Alright, what did we leave off on? E?
Uh,
F. No, we left off on F, right?
oh, yeah.
Alright, G is
2.
2 and H is
5
5.
years old.
My sister's 5.
Alright, you guys want to see how good you are?
Yeah, I want to
okay.
argue with people.
C plus D equals 32.
Okay, I'm writing that. None of you can get it.
I can do it. I can help.
Where's the?
I will not erase it this time.
Yes. Before we erase, we need to write things down.
Calligraphy.
Alright, you guys are in charge now.
Calligraphy.
That's cram.
Face recognition.
No.
No! No, don't do black.
Okay, then what
That
do you
will
want
show
to
up
do?
black. Why did you write it like that?
What is it?
32.
Okay.
That looks like 15.
You're bad.
Okay, what am I?
We should make it smaller.
Anybody
No.
want to do it?
So,
Alright, we need to do
Okay,
another
so.
proportion.
3 times 7
This fell on the floor. Who wants it?
Oh, wait, we have another proportion, Jake. We know 3 plus. Oh, no, we don't. Never mind. I'm sad.
Who took my?
3 plus 7.
Why are you on
plus
shape
2 plus
recognition?
9.
Because he's just like.
Where
that.
did you get 3 times 7? Oh, 3 times 7.
Wait, where's the
Where
other?
did you get the 2
pen?
times 9?
Oh, X times. No, it's D times 9.
Mr. Hudson.
Hmm?
Where's the other pen?
There you go.
Then this equals. Oh, that's the 5. Oh, you're putting the equals around.
Yeah,
Yeah,
see,
it's 'cause
shape
we- shape
recognition
recognition-
doesn't erase. That's the annoying part.
That's the funny part.
No, it's the annoying part.
We're just gonna change this to.
It's calligraphy, not calligraphic.
Yeah, but calligraphic sounds so much more fun to say.
Yeah, it's
Hey, your
funny.
test is tomorrow, by the way.
Yeah.
We
Okay.
talked about that earlier in the week, but just a reminder because I don't like
So,
pop quizzes.
Mr. Allen loves
He
pop
loves
quizzes,
them.
especially when he tells us about
Why
them
are
like
we
a week in
recording
advance.
this?
And this is hint, hint, nudge.
Because then I can flex it on my 8th graders
No.
when you guys solve this.
Hard? No!
Infinite
No!
card! No! How do you want to do?
Infinite. Don't do that.
He did that once when you weren't here and doing the pumpkin thing.
It was funny.
It was not.
Over there. You don't have the pen up yet,
Jake,
Jake.
are you helping or hurting?
3
Hard.
plus 7 plus 9D. No, that's
9B?
Oh
9D.
my god!
9Q.
No! Stop!
9 something. Okay. No, you act up too far. No, we need one more. We need to go forward one more
Okay.
step. No, 2 more
No.
steps.
Just write it down.
No, okay. 9D equals 45
Plus 13C.
plus 13C.
Okay.
And we just need to figure out what one of them
Okay.
equals.
Your
Wait,
D actually looks
wait.
like a Greek letter.
It does what?
There's, I forget which letter it is,
Okay,
but there's a
wait,
Greek
so-
letter that is like,
Lambda.
The
is
Jesus
it
fish?
lambda?
I don't know.
His D, how it kind of looks like,
The
like a
Jesus
weird,
fish.
yeah, sort of. I used to have the Greek alphabet printed so I could refer to it. Now it's all just like related to COVID and it's no fun.
Oh.
They're stealing all the Greek letters.
I'll
Terrible
put it in
joke
the-
I read on Reddit the other night.
You read Reddit?
Why shouldn't you be afraid of the Omicron variant? And this is, it's a bad joke, I'm telling
Why?
you right now. Because the next one will be 3.14 times worse. Pi comes after Omicron in the Greek alphabet.
I hate that.
It's a bad joke. It's horrible.
That's stupid.
Okay.
It was like
What are
way
you
too far of
doing?
a stretch. I also don't know if they're going in
Huh?
order of the alphabet or if they're just
I
choosing
am.
like.
Oh. Wait, what?
Is that 32 minus D? Oh yeah, D. Sorry,
Huh?
it looked like a 9.
What is going on here?
Oh, she substituted.
What?
I'm
Yeah,
sure
I know
explain
you can
yourself.
substitute into the equation, but how did you get? Okay.
You have to go through the octave.
Oh.
Oh.
And then subtract 21 from both sides.
Yeah. Do that. just.
Man, the wrist calculator has changed.
It's actually 441.
No, it's just
You subtract the 21.
It's just 400.
So you,
I was gonna showing my work.
oh yeah, it's 440.
It's actually 440.
Yeah.
Showing my work.
No!
Jake,
Just,
Dude, she's gonna like punch you.
oh,
I probably wouldn't do anything about it.
10. Dog equals 10.
Dog does not equal 10.
It
Dog
doesn't?
does not
Is
equal
equal
10.
negative 10?
Dog does not equal negative 10. The dog is not negative weight. No, he is. That is definitely
26?
20 blob.
No, it's 22.
It's 20.
He just. Oh, it's 20. The dog is 20.
Oh, the dog is 20.
That doesn't work!
That it does. Cat is 12.
No! Oh, yeah, it does. Never mind.
You.
I got it right! Yay! Okay.
We helped.
No, you didn't. I did all of that.
No, your calculator did all of that.
Apple Watch did all of that.
Yeah.
You are
Incorrect.
correct.
Yay!
Nice job, Isaiah.
Yay!
I was gonna do it in more.
So this is part of my test that I'm giving my Math 8 class tomorrow.
It's part of the
Is
test.
it a bonus problem?
No. But it is a group test.
Oh,
We
So,
do a group test.
I'm waiting to see how they deal with this problem because the multifaceted like layering of the fact that you have to figure out this and substitute it in and get down to working with only one variable. And this is a trapdoor because they're going to use 2 instead of 9. They're going to use 4 instead of 13. We're seeing how much they pay
and
attention.
also,
Can
And
we
I
do a
showed
group
this.
test?
I showed this to Mrs. Pettigrew this morning, and she looks at me. She goes, "This isn't on quarter 2, is it?" I go, "Yeah."
Mr. Hudson,
Yes.
I will bet you that it will take them a while to even read this part.
This, yeah, to actually like
Yes.
figure out what this really means. Yeah.
Yeah.
The like
Well, maybe to
A times
comprehend.
B plus C times D equals E times F plus H times G or whatever. Like, yeah, it's like a lot of stuff.
It's even more than that because it's A times B plus.
You want to see what it really is at the beginning? Like, if you just had only like a tiny bit of information, and it's time for you guys to go to lunch, but it would be, like if I didn't know anything else
Your
and
math-
we were starting a problem like this,
Math, before
it would be 13 times C. No, if I didn't know 13, it would be D1 times C plus D2 times H equals D3 times R plus D4 times D. We should probably use something different for dog.
You could use
But seriously,
P for
like,
puppy.
yeah, this is how bad it is when it starts. So you need a little bit of
Mr.
info.
Hudson,
What?
you've been recording this
I
whole
know,
time.
they won't. There's no chance.
If someone got
I may not even upload it tonight,
It'd
but
be funny.
That would be
It'd be
hilarious.
so
yeah,
funny.
but do you think they could replicate your solution process having just like watched the video
No, they
a
just
time?
memorize the answers to be like, it's
You think
so
you can
simple.
memorize? No, you just write down answers. That's a progressing.
Yeah.
Just answers is just a progressing. But all right, have a wonderful day, guys. You know you're always welcome to leave whenever. Hey, did Mr. Hall give you the thumbs up?
Yeah.
Sweet.